Optimizing file size is not as important as it was in the past, when bandwidth was generally much lower than it is now. However, user patience spans are shorter. If a page or image doesn't load within about 5 seconds, you may lose them. They'll browse to another site. So file size is still quite important. Optimizing file size is not much of a consideration if you're only doing print production, with storage being as cheap and abundant as it is nowadays. But large files can make your files difficult to manipulate in your image editing software, especially if you have an older computer. There are a number of factors influencing file size. Pixel dimensions are the most significant factor. Larger images with higher pixel dimensions contain more data and thus have larger file sizes. File format also makes a big difference. Choosing the right format based on the use case can significantly impact file size. Compressed files are smaller, although you may lose some quality in the process of compressing them. Uncompressed files are larger, but the trade-off is that they usually preserve more data and quality. Color bit depth, which I talked about in the last unit, is another factor. More bits per pixel allows for more colors, but increases file size. Additional layers in image editing software like Photoshop can increase file size. Flattening images into a single layer can reduce it. It's important to understand the types of compression when choosing one to decrease file size. Lossy compression reduces the file size by permanently removing or losing some data. The most common lossy formats are JPEG, which is widely used for photographs and real-world images, and WebP, which offers better compression and quality characteristics compared to JPEG. It's ideal for web use. Lossless formats reduce file size without losing image quality, although the file sizes are not nearly as decreased as in the case of compressed formats. The details of lossless compression are not that important to understand, but for the curious, here is a slide that explains it. Others can skip it. The basis of lossless compression is simply abbreviation. That's how it reduces file size. You can see the difference between the uncompressed row of pixels and the compressed one here. If a color repeats across part of a row, the compression algorithm just creates a short piece of code that abbreviates it to avoid repeating the same entire 24-bit number over and over. In other words, the code simply says the color number is X and repeat it 12 times starting here. The lossless formats are PNG, which has the added benefit of allowing areas of transparency in graphics. PNG has two flavors, lossy and lossless. The PNG algorithm determines which one to use at the time of saving the file. TIFF with LZW compression is suitable for high-quality archival storage. Some files do not yield much of a reduction of file size under LZW compression. I'll talk more in depth about specific compressed and uncompressed file formats in a later slide. Best practices for optimizing image file size are the following. Balance minimizing file size with quality of the image. To do this, keep lowering the file size using all of the factors I've talked about in the last slide, reducing pixel dimensions, for instance, until you get to a point where the image quality starts to be unacceptable, and then stop there. There are image editing tools in programs like Photoshop that allow you to do this balancing act during the saving process. It's beyond the scope of this course to describe these, but I'll just mention the two main features of Photoshop that allow you to do this, which are Slices and Save for Web. I recommend that you explore these. Consider the use case to decide how much quality can be sacrificed for smaller file size. For some use cases, end-user bandwidth is not an issue, so you may not need to worry about reducing file size too much. But for some use cases, end-user bandwidth is lower than average, so you should spend some time optimizing the file size. Here's a skills application challenge. Open the graphics program you most commonly use and try optimizing the file size of a test graphic. Play around for a while until you're comfortable doing this. then go to the next video.